So the question says, a scientist is investigating the lengths of the leaves of a certain type of plant. The scientist assumes that the lengths of the leaves of this type of plant are normally distributed. He measures the lengths, X centimeters, of the leaves of a random sample of 8 plants of this type. His results are as follows. So we have all these data points. Find a 90% confidence interval for the population mean length of leaves of this type of plant. All right, so let's answer this question. All right. All right, so for starters, we are going to look for the sum of squares in X and the sum of the terms. All right, so I'm going to do that by storing the information. Here I'll go to stats mod. So mod stat 3 and then option 1. And I'm going to store these values, right? So that means that I'll be having 3.5, enter, 4.2, enter, 3.8, enter, 5.2, enter, 2.9, enter, 3.7, enter, 4.1, enter, 3.2, enter. So that's all the data points, 8 of them. So we can find shift 1, option 3. We can find the sum of squares and x, that's option 1, to be 120.52. So we have 120.52. And we can also find the sum of x, that's option 2, as 30.6. So we have 30.6, right? We also are going to need the critical T value. For the degrees of freedom, it's going to be 8 minus 1, so that's 7. And for the P value, we are saying that this is a 90% confidence interval. So we have 90% and 5% each in the tails. So 5% here. So this whole area is going to be 95%. So for 0.95. All right. So what's that? We go to the tables, critical T value um, table, and we go to 7 degrees of freedom and 0.95, which is 1.895. That's the value we're looking for, 1.895. So 1.895 is what we're going to be making use of. Well, I think what we have is fine. We also are going to need to find x bar is going to be sum of x over n, which is 30.6 divided by 8. And this gives us 30.6 divided by 8. That's 3.825. So 3.825. We're also going to need s squared, which is 1 over 7 of the sum of squares, which is 120.52, right? So that's it. And that's minus 30.6 squared over 8. All right, we do the calculation. So we have 1 over 7. Okay, let's go to normal mode. So 1 over 7, and that's off 120.52 minus 30.6 squared over 8. And this gives us 0.496. I think 643 is better. 643. All right. So that's what we have in here. So we can now calculate the 90% confidence interval, which is going to be 3.825 plus or minus the critical T value 1.895 of the square root of s squared, which is 0.49643 over n, which is in this case 8, like this. All right, so we're going to get the following limits. Let's do the calculation. All right, so 3.825 minus 1.895. All right, and then that's times the square root of 0.4963, and that's over 8, and we get 3.35, and the other one, if we put a plus, we get 4.30 to 3SF. And this here is the answer. That's how we do it for question number 1.